Hi, I'm Robert Harley, editor of the Absolute Sound magazine. We're here in my listening room with Josh Clark of Rockport Technologies, and he's just brought out for me to review the new Rockport Orion loudspeaker here. So before we talk about the Orion, Josh, why don't you tell us a little bit about Rockport in general?
Sure. Rockport Technologies we're a 31-year-old company founded by Andrew Payor, who's still the guiding engineer behind the company and the guiding visionary. And I've worked with Andy on and off for about 25 years now, and recently, back in 2019, purchased the company. And now we work together on product development. And this is actually the first fully joint product. This is still an Andrew Payor product, but we work together on the development of this.
So this is an entirely new from scratch model, not an upgraded. You don't come out with new models very often.
Not very often. And one thing I admire about Rockport is that we keep our models in production for a very long time. We try to put everything we can into a model and keep it going.
So Rockport's known for their heroic cabinet construction. Can you tell us a little bit about this, how this cabinet's made? You can see it's not pieces of flat sheet stock put together. It's called the molded composite technique.
That's right. And well, one thing, this is actually a 31-year process where we've been building dual shell cabinets. So an outer shell, an inner shell separated by a section thickness, which helps with rigidity, and also filled with a damping core material between those layers. So since our first speaker product in 1991, it's been dual shell composites. This product is special because about 5 or 6 years ago, we launched the Lyra loudspeaker, which is still our top product, and it's the best dual shell we've ever made. In that case, it's an outer shell of aluminum and an inner shell of aluminum separated by a viscoelastic core material, or filled with a viscoelastic core material. And our goal with this product was really twofold. The Lyra cabinet is by far the quietest, least noise-making of its own cabinet that we've ever produced. And we wanted to bring that technology to a somewhat lower price point. And so instead of using a cast aluminum on the outside, we've used a cast aluminum structure on the inside and a carbon fiber two-piece outer shell, which is somewhat easier to manufacture, a little bit less expensive to finish, yet having the inner cast aluminum structure where the entire cabinet, all the pieces all the sub cabinets where the drivers for the mid-range and tweeter fire into, and then the bass volume are cast as one single piece of aluminum. And that gives us most of the benefit of the Lyra with somewhat reduced price and just a very small compromise on performance.
And the speaker's $133,000.
$133,000. So it's a very expensive loudspeaker, but we think it truly punches above its weight and really brings a lot of what our $190,000 Lyra speaker brings to the table.
And another benefit of that cabinet construction is you can make the shape idealized for the wave launch from the drivers. You're not on a flat baffle with a diffraction.
That's right. So all of our speakers have similar shapes, but with a molded construction like this, we can have completely beautifully deep rounded edges of the baffle, continuously varying geometry between the drivers. We can really minimize the surface area around the drivers, which helps with diffraction behavior. It's a perfectly seamless edge, so there's no sharp edge where diffraction can really emanate and snap off a sharp edge. And this whole form is optimized for diffraction, for driver placement, so we can put them in time alignment, and also to be the minimum size we could possibly make it to be a full range speaker. And we can there's more to talk about on that. But
And the other advantage is this whole back section is a monocoque construction. There's no joinery. It's one piece, and it gives it structural rigidity.
That's exactly right. I mean, the cabinet is made with 3 primary pieces, but in effect, and we have a really interesting video, it's a little hard to describe with words, but in effect, when the carbon fiber pieces are bonded together and they're bonded in one place around the aluminum casting, and then that's filled with the viscoelastic core material, it essentially becomes a one-piece cabinet with no joinery. So I brought you a 3D printed model. This is actually a scaled version of the actual design of Orion. And the black piece I'm holding is what is cast as a solid piece, or not a solid, but a continuous piece of aluminum. And this is the inner shell of the cabinet. So if you look in here, it may be hard to get enough contrast, but there's bracing built in, all of these driver attachment points, and sub enclosures. So there's a catenary profile mid-range enclosure in there. There's a tweeter enclosure, which is sealed off, and a large base volume. All the volume behind the mid-range and tweeter is used for the base volume. So we're able to, with the stiffness of aluminum, get excellent rigidity, but also really utilize the space inside the cabinet. So this is the inner shell. And then these two pieces, which I'll hold up, are the two-piece carbon fiber outer shell, which is bonded together along that line. And the way the cabinet's built, I'll show you the whole process. We start with the aluminum casting. We put a line of structural adhesive, which is used to put things like airplanes and boats together. It's as strong as the aluminum and the carbon fiber itself. And we bond on the front baffle. And it's a very precise registered fit. There's also a wool felt that fits into this space, but that's part of the finishing of the speaker. So initially that's bonded. Then the next day we turn it over, and there's another mortise and tenon joint around this edge of the carbon fiber and this edge of the carbon fiber baffle and the carbon fiber cabinet piece. And then those pieces are bonded together. So what you have now is a space, and it's a little hard probably to show this on camera, but we do have a really cool video of this on our website. But there is a section between, a space between the casting and the carbon fiber outer shell, and that's filled with about 115 pounds of our viscoelastic core material. Viscoelastic means that it stays elastic, a little bit squishy, and that's what's providing the damping of that aluminum inner piece and the carbon fiber outer pieces, because especially the aluminum by itself is going to ring and vibrate quite a lot if it doesn't have good damping. But just to finish, once that is poured, this has essentially become a one-piece cabinet from those three pieces.
So this speaker weighs a lot more than it looks.
It's very dense.
It's very dense. It's what, 375 pounds?
Yeah, 360. And so there's an enormous amount of density and rigidity in the structure, but there's also a lot of damping. Mm-hmm. And that's, again, with composites, you can get the qualities of stiffness, mass, and damping, which are important. And generally, if you use just one type of material, you can only get one or two of those qualities.
Right, you don't get the combination of stiffness with damping.
That's right.
And all the drivers are all of Rockport's own design, and these are all new drivers just for the Orion.
That's right. So we have, for many, many years, produced our own drivers, with the exception of our tweeters, which had used a ScanSpeak dome and motor system and tweeter assembly with our design of a waveguide and some other modifications. Not only are the mid-range and the woofers all new designs, which we designed and built every single part, but this is our first completely Rockport-built tweeter. And the reason for that is we wanted to make the smallest big speaker we could. And our vision for that was to have just 3 drivers. And to have just 3 drivers develop a lot of dynamics and really be able to couple with the air, you need 3 big drivers. And so we have an 1.25" tweeter, and that mates nicely with a 7-inch mid-range, which really hooks up. It's all about the lower end of their frequency range. So the 7-inch mid-range hooks up with the air very nicely between 100 hertz and 400 hertz, where mid-range drivers are losing traction with the air. The 13-inch woofer has excellent traction with the bottom octave and through the bass region. And the tweeter we had a discussion earlier. In our opinion, it is very important for a tweeter to have full high frequency response to 20K and even good response above 20K. But the problem with tweeters is not the high frequencies. It's their inability to drive the air at around 1K, 2K, their low end of the range. And so by having a waveguide and a larger dome, this tweeter sounds really good down at 1000 hertz, where most tweeters really can't push the air. And that's important because with a bigger mid-range, we want to bring the crossover frequency a little bit lower, because as the frequency gets higher with a larger diameter, the dispersion pattern of the mid-range becomes narrower.
So it has to match the dispersion at the crossover point.
That's right. So we needed a bigger tweeter to make it work. And as with all of our products, the off-axis dispersion is very similar to the on-axis dispersions, which helps it play nicely in a room. So your sidewall reflection is pretty coherent with your direct radiating sound.
And these drivers are is a carbon fiber sandwich, so 2 skins of carbon fiber around a foam core, very lightweight cone core.
That's right.
Now, was Andy the first or one of the first to do that in like 2004?
That's right. He did the first. I think I'll get this right. I believe the Arrakis was the first product that had a carbon fiber. In that case, it was a random-oriented pattern of carbon, outer skin, inner skin, and row of cell core.
Right.
So a sandwich, cord sandwich composite.
You get that lightness and the stiffness by
That's right.
having that beam structure.
And some damping, which all of those things are really important. But in particular, lightness is really important. And so we've done, and there's so much that goes into these cones, particularly the mid-range, because there's a lot of interaction when you have a stiff cone and you have to mate that to a surround. The cone is not flexing, but the surround is absorbing all that energy. And it's a very critical juncture. And we, in addition to doing a lot of theoretical testing, have to make a lot of parts and actually go through extensive laser interferometry testing and acoustic measurement testing to find out how they're performing and then make adjustments. So even the rubber surround, all the pieces that go in that driver are our own tooling and our own design.
Right, and the motor assembly is all of your own design. It's a very sophisticated motor and venting.
Right, which is similar to the completely custom drivers that Andy started working on back around 2010. That was the first year we went to our own motor system, our own basket, our own spider and surround, the whole thing. But previous to that, we had used audio technology drivers, which are excellent, but we wanted to have a little more control, and in particular, reduce air friction, so the actual motion of the air in and out of the driver basket and between the cone and the spider and behind the spider. We wanted to let air flow easily through that. So that necessitated our own basket design, and there are many other things.
I visited Rockport about 10 years ago, and I was floored to learn that Andy hand-tuned every crossover of every speaker that's ever left the factory. He sits on the floor with the crossover, and there's a little extra inductance on the inductor, and a little less capacitance in the capacitor, and he measures it, and he takes a few windings off the coil, adds a little trimmer capacitor in there, and he fine-tunes, because every driver is a little bit different.
Particularly in its out of signal band.
Right. And so he fine-tunes and matches the crossover to that particular set of drivers, and that's still done today.
That's right. And actually, since 2019, I've worked side by side with him in parallel. But previous to me getting there, he was actually soldering each connection. Now I'm soldering, and initially we're clipping on values. And the reason we do that is the drivers are already matched. And they're matched to a very high degree, but where they are, for example, the top end response of the mid-range and the bottom end response of the tweeter, there are variations even with very, very closely matched drivers that we can only account for if we go to this extra step. And that allows us to really reach our reference curve for that particular speaker with every pair we make.
Yeah, I found that interesting that every single pair that's left the factory, Andy's had hands on. And you guys listen to every pair too before it.
That's right. So
is packed.
we measure and calibrate the crossover, and then before the crossover is finalized and built into the cabinet and potted, we listen to the speaker, and now a minimum of 3 of us, often 4 of us, will listen to each speaker, because there are subtleties that we can hear that sometimes don't show up easily in the measurements.
Mm-hmm.
And so we might make a tiny adjustment to a tweeter trim setting, which is barely, if not even
mm-hmm.
at all, measurable.
Mm-hmm.
And we want to extensively quality control each speaker.
Mm-hmm.
So we let it play for hours, listen to it, and then whatever changes we may or may not make, it's then brought back out to the microphone and remeasured before it's finalized.
Mm-hmm. I was also struck when I visited Rockport to see that it was more like a craft shop than a production factory. It wasn't like an industrial operation. It was more like a artisanal craft shop.
Absolutely. I mean, that's one of the things that appeals to me the most about Rockport is the hands-on nature of it. Although we are a production company, we don't do custom products. Mm-hmm. We'll do custom colors, but our products are set, designed, engineered products, but each one is calibrated as if it was the reference standard.
Mm-hmm.
And that's really unique, and I think helps us achieve the consistency in our products that we're known for.
All right. Well, thanks for that overview, and I look forward to reviewing this. So watch for a review in the Absolute Sound in the next few months.
Very good. Thanks, Robert.
Josh.
Thanks for having me.
Thanks.